Okay, welcome back to another memory shortcut video or memory hack video. Today we'll be talking about qualitative analysis. Okay, so qualitative analysis can be quite difficult to remember. So here are some memory shortcuts to remember the test for cations and test for anions. So we start with test for cations, okay? So all the precipitates that are formed, right, they are hydroxides. So let's say you are testing for calcium 2 plus ion. If there's a white precipitate form, the precipitate is called calcium hydroxide. And let's say iron 2, you're testing for iron 2 plus. If there's a green precipitate form, it is called iron 2 hydroxide. Okay, so all your precipitates form are the metal hydroxides. Okay, so how do you remember the color of precipitates form? Firstly, there are two reagents that you use, right, when you test for cations. The first reagent is sodium hydroxide. The second reagent is aqueous ammonia. Okay, so we're going to talk about sodium hydroxide first. So for sodium hydroxide and for ammonia individually, right, there are two observations that you need to look out for. The first observation is when you add a few drops of sodium hydroxide. Okay, after adding a few drops of sodium hydroxide to the solution that you want to test the cation for, you need to look out for the color of the precipitate form. Okay, so you need to look out for the color. So how do I remember the colors? Firstly, ZAC. Okay, ZAC. ZAC will be your white precipitates. So what is Z? Z is zinc hydroxide. A is aluminium hydroxide. And C is calcium hydroxide. Okay, so when you're testing for zinc, aluminium, and calcium ions, they'll all give you white precipitates. Okay, they'll all give you white precipitates. Right. Then the next memory shortcut is forget family car, go ride bicycles. So how did I come out of this memory shortcut? Basically, my family, we were planning to go on a picnic, right? And then we were thinking of whether to use a car to go there or we just ride bicycles there. Then after a bit of debate, we realized that the parking fees there was quite expensive. Okay, so in the end, we decided to ride bicycles, and it's also more environmentally friendly. So the memory shortcut is forget family car, go ride bicycles. FFC will be Fe2 plus, Fe3 plus, and CO2 plus. Okay, iron 2, iron 3, and copper 2. GRB will be green, reddish brown, and blue. Okay, so that is how I remember the colors, which means that if you test for Fe2 plus ions, the precipitate form will be green. Okay, iron 2 hydroxide will be green. If you test for Fe3 plus, the precipitate form will be reddish brown. And finally, for copper 2 plus, the precipitate form is a blue precipitate, copper 2 hydroxide. Okay, so that's all you need to remember for the color of the precipitates. As you can see, Fe2 plus will be green, Fe3 plus is reddish brown, CO2 plus is blue. Okay, then as for NH4 plus, the ammonium ions, there will be no precipitate form. Okay, but there will be ammonia gas release. So you just need to know that ammonia gas will be released. Okay, so that is the first observation, the color of the precipitate when you add a few drops of sodium hydroxide. Now the next step is to add excess sodium hydroxide. So you add more than usual. You don't add a few drops. And then you look out for the solubility. Okay, the solubility of the precipitate. So when you add excess sodium hydroxide, there are only two precipitates that are soluble in excess, which is Za, zinc hydroxide, and aluminium hydroxide. Okay, so if you remember, right, both of them are white precipitates. So when they dissolve, what solution do they form? A colorless solution. Okay, so when you add excess sodium hydroxide, NaOH, zinc hydroxide will dissolve to form a colorless solution. And also aluminum hydroxide will dissolve to form a colorless solution. Okay, as you can see, zinc will dissolve in excess and aluminum hydroxide will dissolve in excess. What about the rest? The rest will remain, which means it is insoluble. Okay, the remaining precipitates are insoluble in excess. Right, so that is for testing for cations with sodium hydroxide. Now let's look at aqueous ammonia. So again, two things to look out for: color of precipitates formed and solubility in excess. So when you add a few drops of aqueous ammonia, for the color of precipitates, it's actually similar to when you add sodium hydroxide, but there are two differences. So the first difference is there will be no precipitation when you test for calcium ions. Okay, remember previously when you test for calcium, there's a white precipitate. But when you use aqueous ammonia, there's no precipitation. Okay, that's the first difference. The second difference is when you test for ammonium ions, there will be no reaction. Okay, because ammonium salts, they don't react with ammonia. Okay, so there's no reaction. Other than that, the colors of the precipitates are all the same. Next thing will be solubility in excess equals ammonia. So when you add excess aqueous ammonia, what will be soluble? Which precipitates will be soluble? Zinc and copper 2. Okay, zinc hydroxide and copper 2 hydroxide will be soluble in excess. So again, zinc hydroxide is a white precipitate. So when it dissolves in excess, it will form a colorless solution. Okay. Copper 2 hydroxide, on the other hand, is a blue precipitate, right? But when it dissolves in excess aqueous ammonia, it actually forms a dark blue solution. Okay, so you have to remember that it's a dark blue solution in excess aqueous ammonia. Yeah, you see zinc and copper. These are the only two that dissolve in excess. And then for copper, it will dissolve to give a dark blue solution. Then as you see the rest, it remains, which means it is insoluble. Okay, the remaining precipitates are insoluble in excess. All right, so that is how I remember tests for cations. Now moving on to tests for anions. Okay, the next memory shortcut is naughty children get caned in school property. So N is for nitrate. Okay, your nitrate ions, NO3 minus. C is for carbonate ions, CO3 2 minus. Okay, G is gas test. So what does this mean? That means when you are testing for your nitrate ions and your carbonate ions, you should be looking for a gas test. Okay, so here's the exact test. For nitrate, right, you add aqueous NaOH followed by aluminium foil, and then you warm the solution carefully. So what will happen if there is nitrate ions, ammonia gas will be formed. Okay, so how do you test for ammonia gas? You use a damp red litmus paper. And since ammonia gas is an alkali, right? It's an alkali gas, the damp red litmus paper will turn blue. Okay, so that is the first test for gas. Then for your carbonate ions, remember your acid reactions, right? Acid plus carbonate give you salt water and carbon dioxide. So if you add any acid to carbonate ions, carbon dioxide will be produced. So how do you test for carbon dioxide? Basically, you bubble the gas formed into lime water. And if carbon dioxide is present, a white precipitate is formed. Okay? So gas test will be for nitrate and carbonate. What about the rest? C is chloride, I is iodide, S is sulfate. Okay, P is precipitate color. That means when you're testing for your chlorides, iodides, and sulfates, you should look out for the precipitate color when you want to observe. Okay, so what is the exact test? For chloride and iodide, is the same test. Okay, so first you add dilute nitric acid, then followed by silver nitrate. So what precipitate should you look out for? If you are testing for chloride, you should look out for a white precipitate of silver chloride. Okay, if you are testing for iodide, you should look out for a yellow precipitate of silver iodide. Right, so if these precipitates are formed, that means the ion is present. So if white precipitate of silver chloride is formed, chloride ions are present. If the yellow precipitate of silver iodide is formed, iodide ions are present. Okay, then finally to test sulfate ions, right? First you add dilute nitric acid, followed by aqueous barium nitrate. So you add barium nitrate to a sulfate ion to form barium sulfate, which is actually a white precipitate as well. So if you notice, if you observe a white precipitate after adding dilute nitric acid and barium nitrate solution, that means sulfate ions are present. Okay, so for chloride, iodide, and sulfate ions, we look out for the precipitate. All right, so that's it for the memory shortcuts. Do let me know what you want to see in the next video in the comments below.